This part of our transformations lesson will be about determining the domain and range of transformed curves when we know the domain and range of the parent function. So I want you to imagine that the function y equals f of x has a domain given by x such that x is greater than or equal to 10 and x is an element of the reals, and a range of y of the set of all y such that negative 2 is less than y, less than or equal to 14, and y is an element of the reals. Well, that's the domain and range of y equals f of x. We're going to determine the domain and range of y equals negative 3f of 12 minus 2x plus 1. Okay, well, first thing we're going to do is clean it up. We're going to algebraically put it in order. So we're going to rearrange our argument and factor out the coefficient of x. And so we've got it stated in a good order for us to determine our values of a, k, d, and c. Now we're going to remember that x always maps on to x over k plus d. Well, our original domain had a relevant x value of 10. Well, what we're going to do is take that x value of 10 and map it on to 10 over k plus d. 10 over negative 2 plus 6 is equal, see, negative 2 and 6 are the values for k and d. That's equal to negative 5 plus 6, which is 1. So on first glance you might say the domain is therefore x greater than or equal to 1, since 10 maps onto 1. Well, that's close, except we have to remember to change the direction of this inequality. And the reason for that is because we divided by a negative value. See, with inequalities, if you divide by a negative value or multiply by a negative value, you need to change the direction of the inequality. And in this case, x was divided by k, which was negative. And so since that happened, we had to change the direction of the inequality on x. That'll happen every time we do one of these domain questions if the k value is negative. If the k value is negative, then that means we divided by a negative quantity, and with inequalities in math, that means we change the direction. If k had been positive, we wouldn't have done that. So anyways, our 10 became a 1, but since we divided by an inequality to get there, our greater than or equal to became a less than or equal to, so our domain will be x such that x is less than or equal to 1. X such that x is less than or equal to 1, and x is an element of the reals. Okay, and now our next part, we have to figure out the range. Well, our original range had relevant y values of negative 2 and 14. So we're going to remember that y maps onto ay plus c, and we're going to say that the first y value of negative 2 will map onto a times negative 2 plus 1. That's 6 plus 1, which is 7. And 14 will map onto a times 14 plus 1, which is negative 42 plus 1, which is negative 41. So our negative 2 became a 7, and our 14 became a negative 41. So on first glance you might say, well, we're just going to put a 7 here and a negative 41 here and be done with it. However, notice that on the way there, we had to multiply by a negative value. We multiplied that x value of negative 2 by a negative 3. In other words, a was negative. And when that happens, we have to change the direction of the inequality. So that less than becomes a greater than, and that less than or equal to becomes a greater than or equal to. So really, this is our new domain. So we write 7 is greater than y, greater than or equal to negative 41. But we know we usually put the smaller values first. So we'll say negative 41 is less than or equal to y. When you read it this way, it's a less than or equal to. And y is less than 7. See, when you read it this way, this isn't greater than or equal to, it's less than or equal to. So we have negative 41 less than or equal to y, less than 7. And that's our range. Okay? Alright, so moving on to the next question. We've got the function y equals g of x having a domain of x less than negative 4, and x is greater than or equal to 3. X is an element of the reals, and a range of negative 2 less than or equal to y less than 6. And we want to determine the domain and range of this complicated function. So what we have to do, first of all, is clean that up. Given y equals 3 minus f of 6 plus x over 2, we're going to say that this is the same as 3 halves minus 1 half of f of 6 plus x. In other words, we have two terms in the numerator, a 3 and an f of 6 plus x, and they each need to be multiplied by a half since our denominator is 2. So that's what we do. We then rearrange things. We put that 3 halves on the end, and we have negative a half f of x plus 6 plus 3 halves. A is negative a half, k is 1, d is negative 6, and c is 3 halves. Now we're going to deal with our domain first. Well, x always maps onto x over k plus d, and our relevant x values are negative 4 and positive 3. So negative 4 will map onto negative 10, and 3 will map onto 3 over k plus d, which is negative 3. And the k value is positive, which means we were only ever dividing by a positive number. So there's no need to change our inequality directions. Negative 4 became negative 10, 3 became negative 3, and there's no need to change our direction of our inequality, so our new domain will be x less than negative 10, x greater than or equal to negative 3. X less than negative 10, x greater than or equal to negative 3. X element of the reals. Our range has y mapping onto ay plus c. Well, our relevant range values were negative 2 and positive 6. So negative 2 will map onto a times negative 2 plus c, and mathematically that's a 5 halves. And our 6 will map onto a times 6 plus c, and mathematically that's a negative 3 halves. So on first glance we just say our negative 2 becomes a 5 halves and our 6 becomes a negative 3 halves. But notice along the way we multiplied by a negative value. In other words, a was negative. A is negative a half. And since a is negative a half, we multiplied the y coordinate by a negative number. We have to change the direction of the inequalities. Okay, so 5 halves is greater than or equal to y is greater than negative 3 halves. But we're going to read it this way because we like to put our smaller values first. So negative 3 halves is less than y is less than or equal to 5 halves. And that's what we've got. Negative 3 halves is less than y is less than or equal to 5 halves. And y is an element of the reals. So you might be coming to an awareness that when a is negative, you'll be changing the direction of the inequalities in the range. And when k is negative, you'll be changing the direction of the inequality in the domain. Okay, one more question here for us. We've got the function y equals f of x having a domain of negative 3 less than x less than or equal to 5 and x is greater than 7. And this range is simply the values negative 3, 1, and 8. We've seen functions where that happens before. We're going to determine the domain and range of this relatively complicated looking function. Well, we have to clean it up first. That's often our first step. And so our argument is negative 1/3 x plus 1. Factoring out the negative 1/3 leaves us with x minus 3. We're multiplying by negative a half and we're subtracting 2 so we can put that negative 2 on the end to help us spot our relevant values. Our a is negative a half, k is negative a third, d is 3, and c is negative 2. Well, x maps onto x over k plus d. And our relevant x values were negative 3, 5, and 7. So negative 3 maps onto negative 3 over negative a third plus 3, and that equals 12. 5 maps onto 5 over negative a third plus 3, and that's negative 12. 7 maps onto 7 over negative a third plus 3, and that's negative 18. Now since our k value is negative, right here, at each one of these steps with each one of these x values we were always dividing by a negative value. So that means we have to change the direction of our inequalities. So we've got a 12, negative 12, and negative 18, but changing the direction of our inequalities means we've got x is less than negative 18 and negative 12 is less than or equal to x is less than 12. And that's what we put. X is less than negative 18 and negative 12 is less than or equal to x is less than 12. and we, of course, we put it into our appropriate set notation form. And lastly, we've got y mapping onto ay plus c. And we just simply had 3 values for y. That'll happen sometimes. And so what we're going to do is take each one of these y values and map it onto ay plus c. So negative 3 maps onto negative a half, which is a, times negative 3 minus 2. That equals negative 1/2. 1 maps onto negative a half times 1 minus 2, which equals negative 5/2. 8 maps onto negative a half times 8 minus 2, which is negative 6. And so our values are negative a half, comma, negative 5/2, comma, negative 6. But we like to put them in order from least to greatest, so we go negative 6, negative 5/2, and negative a half. And so the most complicated part for a lot of people is remembering when to change the direction of the inequality. And so the trick is as follows. We want to make sure that x always maps onto x over k plus d, and if k is negative, then that will imply change the direction of the inequalities in the domain. And of course, we want to make sure that we order it so it goes least to greatest, because that's the standard. And then also we remember that y is going to map onto ay plus c. But whenever we multiply by a negative value, multiply y by a negative value, we have to change the direction. So if a is negative, then that'll imply that we change the direction of the inequalities in the range. And that's basically it. And everything else is just housekeeping and making sure that we put things properly using proper notation.